Hey everybody, Gradius here, and this video is for rationalizing the denominator. Okay, and so when we're talking about rationalizing the denominator, we are talking about radicals, and it's a way of simplifying radicals and simplifying the terms in the radicals, especially when they're in fraction form. Okay, so what we're going to do is so when we had a problem like this, if you guys have not seen multiplying and dividing radicals, please go back and watch that video first. Okay, but before in that video, what we talked about was a square root of 13 over 16. So what we would do right here is we would separate this into we would separate my radical into two separate square root problems. So square root of 13 over square root of 16. We would simplify these. Well, square root of 13 is a prime number. We can't simplify that any further. The square root of 16 is 4. So the answer to this is square root of 13 over 4. Okay, so that's what we did beforehand. Now what we're going to look at is what if I have a problem where I don't necessarily have a perfect square anywhere, especially in the denominator. So the square root of 13 over 17 becomes a square root of 13 over the square root of 17. But now what we need to do is what's called rationalizing the denominator. In math, we do not like to have a radical underneath in my denominator of a fraction. We just don't like it. Okay, it's not supposed to be there. So when we rationalize the denominator, what we're doing is we are getting rid of this radical sign up here, and we're adding it to up top. Okay, so what I want to do in order to get rid of my square root of 17, because again, I have a radical in my denominator, and I don't want that. So what I am going to do is I'm going to multiply this whole fraction by 1. But when I multiply by 1, I'm going to use a very specific number in order to cancel this out. And what I'm going to multiply it by is the square root of 17 over the square root of 17. Square root of 17 divided by the square root of 17 is just 1. This is very similar to if I had to do, say, 1/2 plus 2/3. Well, whenever we add fractions, we need a common denominator. So we would change our denominator here, 1/2. I would change this to 6, so I would multiply this by 3 over 3. Okay, I would also multiply this piece by 2 over 2. The reason why I'm multiplying this by 2 over 2 is 2 divided by 2 is just 1, so I'm not changing the value of this, but I'm just changing the numbers so that they have a common denominator. So it becomes 4/6, which is the same thing as 2/3, and this becomes 3/6, and then I can actually add them. So we're doing the same thing. We're still multiplying it by 1. A number over itself is equal to 1. But the reason why I chose the square root of 17 is that if I multiply the square root of 17 times the square root of 17, that's really just having the square root of 17 squared. The square root of any number squared is the number itself. So it's equal to 17. So it gets rid of my radical. I'm able to find the square root of 17 times 17. So what I'm left with is I have the square root of 13 times 17 all over 17. Okay, and then from here, what I would do is I would just simplify the square root of 13 times 17, and then I would be all done. So if I were to take 13 times 17, I'm going to get 221. So this is equal to the square root of 221 over 17. And with that, I am done. So I do not have a radical in my denominator anymore. And so it changed the whole entire problem just a little, changed all the numbers quite a bit. But the most important thing is that the radical is no longer in the denominator because in math, we don't like it there. So when simplifying radicals, we cannot leave a radical in the denominator. Here are exactly the steps that I just talked about in written form for you. So what I'm going to do is I'm going to do another problem. And what I'm going to do is I'm going to move the radical out of the denominator by multiplying both the numerator and the denominator by the radical value of the denominator. Let's change that. There we go. So my radical value in my denominator is 12. So in order to get rid of this radical, what I'm going to do is I'm going to multiply by the square root of 12 over the square root of 12. So I'm just multiplying my fraction by whatever's in my denominator under the radical. The reason why I do that is the square root of 12 times the square root of 12 is 12. It cancels out the radical. And then I'm left with 14 root 12 on the top. Now what I can do is I can simplify the square root of 12, and then I'll be able to reduce my fraction. These all go from the steps that we learned before when multiplying and dividing radicals and simplifying them. So square root of 12, let's just simplify that real quick. This is equal to the square root of 4 times 3, which is 2 square root of 3. So the square root of 12 becomes 2 square root of 3. So now what I have is I still have this 14, and this is being multiplied by 2 times the square root of 3 over 12. 14 times 2 is 28 root 3 over 12. And now I can reduce 28 and 12 by dividing by 4, because I'm going to divide by their greatest common factor. I can divide both of these by 4, which is going to give me 7 square root of 3 over 3. And this is all the way simplified. Okay. Let's look at it something if we had variables. If again, I have a radical in my denominator and I want to simplify this. So what that means is I want to get the radical out of my denominator. So I'm just going to multiply by whatever's under the radical, which is just x. So I'm going to multiply this whole fraction by the square root of x over the square root of x. This is equal to just x on my denominator. That's the whole reason why we did it. And then I have x square root of x on the top. Okay. Now I want to reduce, and x over x is just 1. These cancel each other out. So what I am left with is the square root of x, and I'm done. This is a much more simplified version than this. This looks kind of complicated, but this is really just equal to the square root of x. So we are all done. Another one. So now I've got a couple of things going on. I have the square root of 25 over the square root of 54. Well, the first thing I know is, let me just start simplifying this a little bit right away. Square root of 25, that's just 5. So let's make this a little bit simpler. Square root of 54, I can actually simplify this too a little bit, and I want to do that right now just to make my life a little bit easier. Because this is the same thing as the square root of 9 times 6. And 9 is a perfect square. So really, what I have is 3 times the square root of 6. So I have 5 over 3 square root of 6. Now, I want to get rid of my radical in my denominator. I'm only going to multiply by whatever is under the radical. I'm not going to multiply by this 3 here. So when I multiply, I'm multiplying by the square root of 6 over the square root of 6. Now what I have is 5 times the square root of 6 in my numerator. And then I just have 3 times 6 in my denominator. The reason why I have 3 times 6 is because the square root of 6 times the square root of 6 is 6. And so then I still have this 3 out here. So I have 3 times 6, which is just 5 root 6 all over 18. These do not share any common factors. I cannot reduce the square root of 6 anymore, so I am all done. Had I not done this step first, had I just multiplied all of this by the square root of 54 in the beginning over square root of 54, I would have gotten the same answer, but I would have had to actually reduce in the end instead of simplifying in the beginning. That's the only difference. One last problem with more variables, x to the third over the square root of x to the 7th. So what we're going to do is let's go ahead and multiply by the square root of x to the 7th first over the square root of x to the 7th. Let's get rid of that radical. When I do so, I have x to the third times square root of x to the 7th all over x to the 7th. Now what I want to do is, before I even start simplifying this, I want to simplify x to the 7th first. So if I have the square root of x to the 7th, we know that this is the same thing as the square root of x squared times x squared times x squared times x. This is x to the 7th, just expanded out a little bit differently. I know that the square root of x squared is x. Square root of x squared is x. Square root of x squared is x. So I'm left with 3 x's on the outside, 1 x under the radical, which simplifies to x to the third square root of x. So what this simplifies to is I have x to the third times x to the third. I have x to the third, I'll just rewrite it all out, x to the third square root of x all over x to the 7th. X to the third times x to the third, this becomes x to the 6th square root of x over x to the 7th. I can reduce these because this is x to the 6th over x to the 7th. So these are I'm going to subtract 6 minus 7. When I do so, I will be out of x's up here, and I'm only going to have one x left over down here. So the answer is the square root of x over x, and I'm done. Okay, so big thing, you guys, when rationalizing the denominator is just multiply both the numerator and the denominator by the radical value of the denominator. So we're going to multiply by the radical value down here, both of them, and then we're just going to use all the properties we've learned from simplifying afterwards. I hope this video helped. Thank you for listening. Have a great day, guys.